We ended the last video where I talked about contrasts of C, my new contrast. That what I'm looking at is the comparison via dummy codes between my four categories. And here what we discussed is the idea of dummy codes, and I just introduced one. The focus of this video is on dummy coding, which is specifically coding ones and zeros for the different categories. And it's the logic of dummy coding and the categories and how we code them that is important, because it sets up the comparisons that we are testing explicitly. So to begin, this comparison is a comparison where cat becomes the base comparison for fish, pig, and dog. And how do I know that? Because of the coding implies that for fish, only the fish get a 1 for the fish variable, and all of the other categories get a 0. And all of the pigs get a 1 for the pig variable, and all the other categories get a 0. And for dogs, similarly, all of the dogs get a 1, but cat, fish, and pig, the other categories, get zeros. And missing in all of this is cat, because there is no cat dummy code. Cat is implied. It becomes, because it's implied, it is the comparison for fish, pig, and dog. That is, it stands as the comparison for fish, pig, and dog dummy codes. Now, what happens if we don't want to compare cat to all of the other animals? Well, what we do is we create a different contrast, and we create a contrast that enables us to compare what levels we do care about. So here I've created a new contrast or dummy code, and you'll notice that dog gets all zeros, as opposed to before cat got all zeros. So dog becomes the comparison group. Dog becomes a comparison group to pig, fish, and cat. Now the beauty of this is the flexibility. You can create hypothesis tests with dummy codes where you can have a base comparison to all of the others. So suppose I hypothesized that dogs were superior to all other animals. Well, certainly I would want dog as the base comparison and have it compared to pig, fish, and cat, which is not what happens here. Cat becomes the comparison. But that's the reason why I changed the contrast coding. So C, capital D, means the contrast for dogs. It's the same variable because I cut X into 4 discrete levels: cat, fish, pig, and dog. It's the same categorical cuts that I made before. I just changed the contrast coding. So I have treatment coding, which is dummy coding in R, and I have the base comparison as the fourth level. Okay? By making the 4th level dog as the base comparison, I changed my contrast coding and changed my hypotheses. Similarly, what I want to show you is what happens when we create a C2, which is a binary split, and you'll notice that we only have one dummy code, dog. Okay, you'll also notice that cat gets a 0. So cat becomes the base comparison for dog, and this is just one single dummy code out of this, and the reason for it is we get the same. If we have k categories, in this case 2, we will get k minus 1 dummy codes. Similarly, we have 4 categories here: cat, fish, pig, and dog, 4 categories. And so we will get k minus 1, or 3 dummy codes: fish, pig, and dog. You'll also notice here that fish, pig, and dog, those labels go away. We don't have the labels anymore. And because we don't have the labels, we have to know what 1, 2, and 3 are. It's a little bit more convenient when it's fish, pig, and dog as labels like that, because it's easier to follow. Nevertheless, if we can always go back to the contrast matrix, you can always see what these codes are, and you'll see that you need to know what these codes are when you start looking at the results. And I'm just going to run these bivariate models, and you'll notice here where I have a linear model with C predicting happy. So C is predicting happy, and you'll see C fish, C pig, C dog, and each one of these is a predictor of happy. And remember that this is fish compared to cat, pig compared to cat, dog compared to cat. And each one of these is a comparison. So I have 1.9, 3, and 5.4, okay? Then I go to C dog, okay, CD, and you'll notice that now it's replaced with CD1, CD2, and CD3. And we need to know what the contrast matrix is in order to interpret that. So remember that 1 is cat versus dog, 2 is fish versus dog, 3 is pig versus dog. So if I go up here, after looking at that, now I know this is cat versus dog, minus 5.4. Notice that it's very similar to 5.4, but in the opposite direction. Then it's 3.4. Well, we didn't get a 3.4 before because we didn't make that comparison. And then it's 2.3. Again, this is now pig versus dog. We never made that comparison. So all of these are just comparisons. Now here I only got one comparison because this is dog versus cat, and this is 1.7. Okay, so now what we have is we have a comparison of each one of these categories. And remember that dog versus cat, was a bivariate median split for my x variable, so this parameter will not be the same as any of the other parameters. I just wanted to show you the difference between for the k-1 logic in the dummy codes. So this is how we set up coding, dummy coding in particular, for categorical or nominal level data, and the logic behind dummy codes. Dummy codes are always a comparison between some base category and the other category levels. Okay, so stay tuned for the next video where we're going to interpret these results.